So we are making bouncy balls. We're taking this polymer powder, pouring it all the way into this mold. Get it all in there. Then we'll put it in the cup. Fill it with water. And as the water soaks into there, it's going to form the polymer, will return in a bouncy ball. And the kids will be able to take it out and then take it home with them and have a super ball at home. Alright, so we take it out. See, now it's no longer a powder, it's a full ball. Dump the water back in. And then once it hardens, then it'll start to bounce.
Hi, I'm Jurassic Jess, and this is dry ice. Dry ice is colder than any ice cube you find in your house at home. It's smoky because it's frozen carbon dioxide. We can place it in environments like water. We can place it against solids and play musical instruments. But most importantly, we can also make it do a bubbly wonder. Place it inside here and take a look at my bubble volcano. Nice warm soapy hand mixture for you.
Hi, I'm Heather Kearns-Latini. I'm with the Ewing Public Education Foundation, and we're here tonight as one of our grants for the Hands-On Science with a Dash of Math. We basically are a nonprofit that raises funds to give back to the Ewing Public Schools. We do that through donations, individual, teacher donations, corporate. Tonight is actually funded by one of our big funders, the New Jersey Manufacturers and JM Insurance Group.
Hi, I'm Ingrid Washington. I teach kindergarten here at Antheil, and I'm so happy to be here. And my activity is magnets, exploring magnets, which fits right in to our STEM program because it's exploration. The children can be physicists. They can see what propels a magnet, positive, negative effect. It's a lot of free exploration and creative thinking. So they have different kinds of magnets, and then they can see the materials. What is magnetic? What is polarizing? What isn't magnetic? Obviously magnetic. And then what would you do with another magnet? So they can do a lot of different things. And what happens if you have two magnets together? Does it come together? Does it pull apart? Oh, I feel a little friction. So I've just learned a lesson right there. So that they do not come together. There is a polarized pull apart.
We have a vortex cannon, as you can see. If we just sit here and use the other one with no fog smoke, you can't see it. When we put the fog smoke in, you get to see a vortex ring.
It comes out like a circle.
What we're going to be doing is you guys are going to be using our little vortex cannon.
Alright, the first thing you have to do is pour a thin layer of milk on our plate.
And then you're going to drop in a few drops of food coloring, whatever colors you want. So get some red.
The more colors, the prettier it'll look.
Oop. Oh. And then you'll drop in some green and maybe some yellow.
And we stuck a Q-tip in liquid dish soap. You stick it right in the middle. You can see the colors start moving all around your plate. You can switch it around. And what the Q-tip's doing is breaking the surface tension that's on the surface of the milk.
And it makes the colors go everywhere, make it look like fireworks.
Okay, so today we are going to learn how to experiment with a levitating ping pong ball. Now it's very simple. You don't have to have a classroom teacher give you these materials. You can find them at any department store where you live or maybe in your house. All you are going to need is paper, a straw, and a ping pong ball. That's all you really need. I miss you. First thing that you are going to do is you need to fold it like so. And your preference or not, you can have tape, maybe you don't need tape. You're going to place the ping pong ball once you crunch the ends tight enough underneath. With the bendy straw, you want it on a 90-degree angle. Make sure you have enough room. You want the funnel part up wide enough. And once you blow in, you'll eventually see the ball levitate. Thank you for your time. I appreciate it.
It's a glow board, and this is a touch sensor. It catches. Hold it, and I'm going to drop down.
You're going to either stretch that, right, so that they're nice and thin like wisps, and you're going to push them into the bottle and fill it up until you get to this first line. After that, we're going to pour in your first color. Okay, so your first color and then your glitter, and then we're going to do another layer of cotton balls, because what's going to happen is these are going to collapse, right? Because they're going to get wet and they're going to get soggy, so they'll go down to this size, and then we're going to fill it up again, and then pour in your second color, and then your third color.
Beth, all right, I'm going to pour a little bit more so we can soak up that cotton ball.
Yes, Queen. All right, let's get more water in there.
Okay.
I keep saying yes, Queen.
Yours is so tiny. Could you?
Because
I shoved it out a
All right,
lot.
ready? Hold on to the bottle.
Kool-Aid Jammers.
Oh my god, it's so cool.
This reminds me of Kool-Aid Jammers
All right,
now.
now let's see.
Hello, we're going to be making parachute men here. We have a number of materials to choose from that may or may not work to make a parachute. So first you need to imagine what your characters and how they're going to land. We have our little blue guys, different colors over here. You want to make sure that they're going to land safely. So then you need to make your plan to make your parachute, and you need to test it, of course, and then from there you improve it.
We'll be taking markers and putting them on our toothbrushes, and they're electric toothbrushes, and we will turn them on and they're gonna draw and bounce around on the paper and make all fun things. You can also take them and draw your name on it and make it 3D.
What you're going to do is you're going to push the towel into these so they overlap, so each part of the towel touches each cup. So you do want to push the towel in. There you go. And then you're going to push it into the red too. And then this end piece right there. And then push this one in. Yeah. And then you can use that towel to dry your hands.
So what's going to happen is that the colors are going to absorb up into the towel. And eventually, if you look at that one over there, see this one's been sitting for a while, so they've started to connect. So you have red and blue, but in the middle where they've connected, you get purple. So that's why it's the walking rainbow, because it'll go over and eventually make all the colors.
Blue, red, purple, green.
So if you see over here on yours, I see the blues already coming over. So if you let it sit for a while, eventually they'll all absorb over.
We're gonna binary code some bracelets, so the kids are finding the first initial of their first name. So mine is M, so it'll be a pink bead, a white bead, a pink, pink, white, white, pink, white, and this is our final little bracelet.
All right, so we're following the pattern with her name. It's Simalee. Simalee, so it's pink, gold, to spell out her name. And
Mine. My name's Irene.
So I'm gonna take this can, I'm gonna flip it, and it crushes. I started by heating this up, right? What happens when you heat things up? Like if you heated a balloon, what would happen to it?
Pop.
It would pop, right? Because it expands. The air is expanding inside and
there's
going
air inside the can, right?
and being pushed out of the can. And then what I do is I take it and I flip it over and I basically seal this can with the water, right? And now I cool that can. Like it just almost instantly cools the can. So what happens to the air when I cool the can?
it comes out.
It doesn't come out. If it expands when I heat it, what happens when I cool it?
If everything's spreading out inside that can when we're heating it up, when we're making it cold, it's coming back together really, really quick, right? So we can think that the air is spreading out, and then when we put it in the cold, it's coming back together really, really quick and tightening up, right? And if it did that, would it make sense that it would smush? Yeah.
All right, there's 3 balls, and what we're going to do is we're going to shoot these balls down this track, and we're going to see which one comes out the end fastest. 3, 2, 1. So this red ball, the one that was here, went fastest, because what happens is it has this really low valley, and when things drop down, it goes faster. So because it dropped down here and it went fast for a really long amount of time, it managed to reach it to the end first.
So welcome, we're from the Franklin Institute of Philadelphia, Pennsylvania, and we're talking about structures and how you build things. So a quick lesson would be, when you try to build something, maybe you want to build with a square, and that looks like it should be pretty good, but squares tend to fall over, not so good. So what can we do to make a square stronger? Well, maybe we can put in a piece of cross bracing like this, and that's pretty good. It's not moving that way, but it's still sagging that way. So maybe we put in 2 pieces of cross bracing like this, and now our square stays square. But something else interesting just happened. We turned our one big square into 1, 2, 3, 4 triangles. And when you're building bridges and roads and all sorts of structures, triangles tend to be a much more rigid or stronger shape. They don't break down and wiggle and waggle as much. So many of the times what we try to do is to build with triangles. And that leads us over to where the young man is working, where he's working with truss systems. And truss systems can be made out of metal, or truss systems can be made out of wood, but truss systems essentially make a lot of triangles so that you have bridges that you probably recognize that go across your river or stream and are in your town or village. These are all called truss bridges. But there's another kind of bridge we can talk about too, and that's an arch bridge. So an arch is usually made out of pieces. Now, we're from Philadelphia, Pennsylvania, and maybe you know that Pennsylvania is called the Keystone State. Well, here's why. If I take a bunch of these blocks and I start to put them together, the blocks, after a while, get kind of hard to put together and they just fall apart. But if we build them very carefully from both sides, we can do something very interesting. We can get them with a center keystone to hold together. And now we have what's called an arch. And an arch holds a lot of weight without collapsing. And that's why Pennsylvania is the Keystone State, because it held the colonies together.
Yeah. Are we on the news? Interception. Interception. Okay. What doing? It's Moss.
A really cool design that the students on the team came up with, where it has a cam that rotates and it pushes the ball into the wheel. Really cool.
Alright, you're gonna stick your finger in the water, count how long you can keep your finger in there, and then you're gonna pull it out when you're done. Are you counting? Alright. It's probably gonna be a while. You look tough. Does the cold bother you? Oh, it's cold. Alright, now we're gonna put some Crisco on it. It feels slimy, just go like that. We're gonna wash it off, I promise.
He's dramatic too.
Magic.
Embrace. What is that? Alright, ready? Dip it in that one and see if you can do it for a longer time, okay? Go ahead. How long?
26 seconds.
Whoa! Let's wipe your finger. Why do you think you kept it in here longer?
It's probably because of the warmness of the Cisco.
The Crisco, yep.
These two up with water. All right, so you're gonna take these 2 cups and go over there and fill it up with some water, okay? 6. All right, then you're gonna take this.
It looks so cool.
I know, right? Then you're gonna stir it all around. You want both in there, or you want one?
It's
You guys
just like
coming down?
outside when you see the
Yeah.
clouds fill up with water and then it rains.
Exactly.
Oops.
You gotta keep doing it, all right? You start seeing it more and more. See? See how it's coming down? That's pretty cool, right?
Do you want to pet one of the tortoises? It's 4. Come here,
wanna touch the tortoise?
Come here, you want to touch the tortoise?
I want to touch the tarantula.
I remember when he We're not going to take it out because the tarantula bites, but you can hold it.
Yeah, because that makes sense, right? Because
So
Stella was
first
okay,
grade.
and so you had 3 girls.
You
can't pick it up.
Yeah, we're not going to pick it up.
Here, I'll help you.
Thank you.
No, put it all in. No, put the whole thing in. Put the whole thing in.
Oh, 3 of those.
Yeah, 3 whole things, not 3
These
drops.
things are so weird.
Yep. Go ahead.
So hard.
Yep. Okay.
A way you can fill it all the way.
No, don't squirt it.
Is by doing that and then from the rest of them.
All right, one more. Okay, set the pipette down. Now what you want to do is put half a spoon of this in.
Beep.
Then you seal it,
Mhm.
and you look at it and feel it.
Beep. Very cool.
It's getting cold. That's because here, put it all down in one corner. You can feel it better. Some chemical reactions require energy, and so it's taking heat energy from the air in your hand.
It's so sloppy! Yeah, I know. It's so sloppy. Yeah. No, I just need to
I'm going to gently squeeze, because if we squeeze too hard, it's going to spill everywhere. And we're going to squeeze some water, and we're going to count. 1, 2, 3, 4. And we're going to do this until the water spills off the penny. So then they would keep on going. 5, 6, 7, 8, 9, 10. And I'm not very good at dropping it, but eventually it would form a dome. And then they would count how many they would get on each penny. Then they would do 3 trials and find the average of the amount of drops that would be on the penny.
So what do you think is going to happen when we do this?
Probably marshmallow.
Yep, it's
We're going to add a little bit more.
Probably not going to work.
Yeah, I was going to say because we went last week, so I thought.
Not gonna
work? No, it actually does.
Alright.
Perfect. Okay. So now I'm going to ask you to hold this water bottle.
Oh, no. I know how to
And
do
I'm
it.
going to put this.
Oh! Right? So what I want
Isn't it so cool?
Yes!
And it's fizzing.
Put 2.
So what do you think is in this balloon now?
1 scoop.
Air, but what type of air?
Very nice, very nice.
Thank you.
You want the whole thing? Okay, and then after that, we're gonna add what color do you want? The consistency is a little more loose.
Is your room?
Yeah?
No.
Is that how you wanted it?
Wow, you did a good job. Penny, can you start? Put this down. Come on, shake Ethan. Ethan, look at the camera. Smile.
Guys, not that good smile. Where's the creek?
put the balloon over it.
Oh, okay.
And now we're going to take 3 pieces of tape, about 3 inches long, and tape it down, and you have your vortex camera. Okay. One moment, we'll do the door.
All right.
There you go.
So I can do that over here, right? Will we go through there?
You can probably closer because
Probably closer?
Yeah, like that.
But see,
Oh,
you
I
don't
can see it
see
moving. Let's see here.
That's why we call it invisible energy. Because you can't see it unless you put a little smoke.
Okay, this is here. It's better. Oh, that's fine.
What does it mean when you hear the word levitate? When I think of it, I mean, let's see, something that's floating in the air. Today I have my lovely assistant, Miss Lippincott, who's going to show you an easy, cost-effective way on how you can experiment levitation. All you need, go ahead.
All you need is a straw and a ping pong ball.
That's
and
right.
of course, your air in your lungs. Take a deep
Mhm.
breath in, and you're going to do a continuous exhale out.
And watch the magic. That is awesome. Thank you for spending the time with